Something is tearing the universe apart right now, at this very second, and the terrifying part is, scientists have absolutely no idea what it is. Not a theory, not a guess close to being confirmed. Completely unknown. And here is the part that should keep you up at night. It makes up 68% of everything that exists. Let that sink in. 68% of the entire universe is something we cannot see, cannot touch, cannot detect directly, and cannot explain. We gave it a name, dark energy, not because we understand it, but because we needed to call it something. Naming it was the easy part. Everything else has been a nightmare. Go back to 1998. Two separate teams of astronomers were studying distant supernovae. These are exploding stars so bright they can outshine entire galaxies. They were using these explosions as cosmic measuring tools, trying to calculate how fast the universe was expanding after the Big Bang. Everyone assumed the expansion was slowing down. Gravity pulls things together. That is basic physics. The universe should be decelerating. That was the expectation. What they found instead broke physics. The universe was not slowing down. It was speeding up. The expansion was accelerating. Those distant supernovae were farther away than they should have been if gravity alone were governing the cosmos. Something was pushing space itself outward, not from a center point, but from everywhere simultaneously. Something embedded in the very fabric of space was winning against gravity, and it was getting stronger the more space expanded. Saul Perlmutter, Brian Schmidt, and Adam Rees won the Nobel Prize in Physics in 2011 for this discovery. But winning that prize did not answer the question. It just made the question louder. What is doing this? Here is where it gets philosophically terrifying. The leading candidate is something called the cosmological constant, originally introduced and then abandoned by Albert Einstein, who called it his greatest blunder. Einstein added it to his equations of general relativity to keep the universe static because he believed the universe was not expanding or contracting. When Edwin Hubble proved the universe was indeed expanding in 1929, Einstein threw that constant out. Decades later, dark energy resurrected that exact constant, and now it sits at the center of modern cosmology, haunting us. The cosmological constant suggests that empty space is not actually empty, that even a perfect vacuum has energy, a baseline energy baked into the structure of space-time itself. This is called vacuum energy. And when physicists calculate what this vacuum energy should theoretically be, using quantum mechanics, they get a number that is 10 to the power of 120 times larger than what we actually observe. That is not a rounding error. That is the largest discrepancy between theory and observation in the entire history of science. Physicists call it the vacuum catastrophe, and it is arguably the most embarrassing unsolved problem in modern physics. Now stop right there, because here is the controversy nobody wants to say out loud in polite scientific company. Some physicists believe dark energy does not exist at all. They argue the data is being misread, that our models of the universe have a flaw we have not identified yet, and that we are chasing a ghost. A 2023 study from the University of Waterloo re-examined the supernovae data and proposed alternative interpretations. Meanwhile, a 2024 analysis from the Dark Energy Spectroscopic Instrument, DESI, released results suggesting dark energy may not be constant. It may be changing over time, which would shatter the cosmological constant model entirely and demand a completely new framework. Changing over time. That is not a small update. That is the equivalent of discovering the rules of chess change every few moves and nobody told you. If dark energy is dynamic, if it evolves, then our predictions about the ultimate fate of the universe are wrong. And those predictions are already disturbing enough. The most widely accepted scenario based on current data is called the Big Freeze. As dark energy continues accelerating expansion, galaxies drift apart. Stars burn out. Black holes evaporate over incomprehensible timescales. The universe approaches absolute zero. Silence. Nothing. But if dark energy strengthens over time, we get the Big Rip, where expansion accelerates so violently that it eventually tears apart galaxies, then solar systems, then planets, then atoms themselves. The The very bonds holding matter together would snap. Physicists calculate this could happen in roughly 20 billion years, or sooner, depending on what dark energy actually is. And we do not know what it is. We launched the Euclid Space Telescope in July 2023, specifically to map dark energy across the universe with unprecedented precision. NASA's Nancy Grace Roman Space Telescope, planned for 2027, will add another layer of observation. These are not small projects. These are humanity's most sophisticated attempts to understand a force that governs the destiny of everything. Every galaxy, every star, every atom, every version of you that has ever existed. Here is what makes this genuinely profound beyond the science. For thousands of years, humans looked at the sky and thought the universe was stable, permanent, eternal. Then we discovered it had a beginning. Then we discovered it was expanding. Then we discovered something unknown was accelerating that expansion. Each revelation made the universe stranger, more violent, and more mysterious than the one before. We are not the center of the universe. We are not even made of the dominant substance in the universe. Ordinary matter, everything you see, touch, love, breathe, and are, accounts for only 5% of the cosmos. Dark matter is another 27%. And 68% is this unnamed, unexplained, potentially evolving force that will decide when and how everything ends. The universe is under no obligation to make sense to us. Follow this page, because the questions we cover here are not just interesting. They are the most important questions the human mind has ever asked. Now tell me this in the comments. Does it disturb you more that the universe will end, or that we still cannot explain the force that will end it?